Hi guys, so today we're going to take a look at question 1 from the paper 1 of the 2016 exam. Okay, so we start off, so we have minus 4 plus 3i is one root of the equation az squared plus bz plus c equals 0, where a, b, c are real and I squared is minus 1. Write the other root. Okay, so this is actually just a very nice, very quick start to the question. So we have a root and it's a complex root. So we immediately have the conjugate root theorem. Conjugate root theorem, where if a complex number is a root, theorem, if a plus bi is a root, so is its conjugate. A minus bi. Now this is just something that you need to know to do this question. So if minus 4 plus 3i is a root, then minus 4 minus 3i is also a root. So our answer is minus 4 minus 3i. Now on to part B. Use de Moivre's theorem to express 1 plus I to the 8 in its simplest form. Okay, so straight away, what's de Moivre's theorem? De Moivre's theorem. I'm aware I might be butchering that pronunciation. Okay, so if we go to the log tables, we see that de Moivre's theorem is r cosine theta plus I sine theta. So kind of the trigonometric way of writing a complex number to the n is equal to r to the n cosine n theta plus I sine n theta. Okay, and we want to use this to write 1 plus I to the 8 as its simplest form. So we're going to be using this side of the equation, because this side is a complex number to the power of something, and we have a complex number to the power of something. And now our job is to write 1 plus I in the form cosine theta plus r times cosine theta plus I sine theta. Okay. Well, what is r? Well, r is the magnitude of the complex number. And the magnitude of the complex number is the square root of a squared plus b squared, where our complex number, where z equals a plus b I. Okay, so our complex number is 1 plus I, so a and b are both 1. So r equals the square root of 1 squared plus 1 squared, which is just the square root of 2. Okay, so 1 plus I equals the square root of 2 times cosine theta plus I sine theta. Okay, well now what's theta? Well, if we have our kind of complex plane here, and let's say our point is, well, our point is 1 plus I, so let's say this is the coordinate, so it's here, 1 plus I. Then if we connect our point to the origin, theta is the angle it makes with the x-axis. So typically how we measure angles in trigonometry. So this is our theta. Okay, and now since the height, that's not right, since the height is equal to the width, theta is just a 45-degree angle. So theta is 45. Theta equals 45 degrees. Okay, so 1 plus I is equal to root 2 times cosine 45 plus I sine 45. Okay, and now we can use de Moivre's theorem. So we have 1 plus I to the 8 equals this thing to the 8, root 2 cosine 45 plus I sine 45. And then we just use de Moivre's theorem. So de Moivre's theorem says that this is our magnitude, which is root 2 to the 8, times cosine 8 times 45, 8 by 45, plus I sine 8 times 45. Okay, and now root 2 to the 8, if we just do that on our calculator, is just 16. And 8 times 45 is just 360. And cosine of 360 is just 1. Plus I times sine of 360, but sine of 360 is just 0. So it's just 16. So that's 1 plus I to the 8 in its simplest form. Now on to part C. 1 plus I is the root of the equation z squared plus minus 2 plus I z plus 3 minus I equals 0. Find its other root in the form m plus ni, where m and n are real. Okay, now you might be thinking, well, why don't we just use the conjugate root theorem again? And the reason that we can't use the conjugate root theorem is that the conjugate root theorem only works when you're working with a real polynomial, so a polynomial with real coefficients. And you see in the first statement that this polynomial does have real coefficients, so we could use the conjugate root theorem, but here it doesn't, so we can't. So let's just get to writing down the points of interest. So here's our equation, z squared plus minus 2 plus I, z plus 3 minus I equals 0. And we know that 1 plus I is a root of this. And because of the factor theorem, we know that z minus 1 plus I is a factor. And so now what we would typically do is we would divide our factor into our polynomial and get the other factor, and then that would give us the root. Okay, so z minus 1 plus I into z squared plus minus 2 plus I z plus 3 minus I Okay, now z goes into z squared one time, and now we get z squared minus 1 plus I z, and now this becomes a plus, change the sign, we get a 0 plus minus 1 plus 2I z, bring down the 3 minus I, and now we want to divide z into minus 1 plus 2iz, which is of course minus 1 plus 2I. And now if we multiply that back, we get minus 1 plus 2I z, and then minus 1 plus 2I by minus 1 plus I. Let's just do that here. Minus 1 plus I by minus 1 plus 2I. And now we'd like it to be 3 minus I. So we get minus 1 minus I plus 2I, and then 2I by I is just minus 2. So this, we get minus 3, which is just 3, and then minus plus I, which is just minus I. So we get plus 3 minus I as we would like. And then you change the signs, and this is 0. So the other factor is z plus 1 minus 2I. And if z plus minus 1 plus 2I is a factor, then minus 1 plus 2I is a root. That's just the factor theorem. So then the root is just 1 minus 2I. And that's our other root.